Okay, so we're going to have a look at what happens in a bit more detail, what happens when you electrolyze aqueous solutions. So in the previous video, we've already seen what happens when you electrolyze aqueous sodium chloride. So here, right, you have, so the positive ions you've got there are Na plus, and the negative ions are Cl minus. Now, what do we get formed at the negative electrode? Right, the sodium ions are not released there. You get hydrogen gas released there, remember? And that's because hydrogen ions come from the water, and whenever the metal is more reactive than hydrogen, which is nearly every metal except copper, then you don't get the metal released at the negative electrode, you get hydrogen gas. And formed at the positive electrode, well, the chlorine gives away its electrons, and you do get, chloride ion gives away its electrons, you get Cl2. And if you remember, what's left in solution is NaOH solution left over. Okay, let's do copper chloride now. So copper chloride, of course, you've got negative chloride ions, you get chlorine again at the positive electrode, but the negative electrode is different because copper is less reactive than hydrogen, so you do get copper metal deposited there. Sorry, copper metal deposited there. All right. We've got copper sulfate. Well, again, we've got Cu2 plus ions. You're going to get copper metal deposited there for the same reason as the other one. But here, now you may think, well, what's going to be made at the positive electrode? You may think sulfur dioxide or something like that. Well, it's not. The sulfate ions stay in solution. They remain chemically unchanged. And what happens is you get oxygen being given off. Right, where is that oxygen coming from? It's coming from the water. And we'll talk about how it's formed in a minute. Okay, and we'll talk about what's left over as well. Right, let's get on to sodium bromide. Right, okay, so you've got sodium, positive sodium ions in solution. So yeah, you're not going to get sodium metal, you'll get hydrogen. Now, bromide ions, like chloride ions, of course, in the same group, periodic table in group 7, you will get bromine gas produced there, or bromine in solution. Bromine, it will be in solution, and it will come out as gas. If you do sodium iodide, again, you get hydrogen gas given off there because the sodium is more reactive than hydrogen. And again, it's another halogen. The halogen, the halide ion, iodide, does give away its electron, and you get I2 being formed there. Let's look at this last example, copper nitrate. Well, with copper nitrate, you are going to get copper. It's less reactive. You get that at the you get copper at the negative electrode, and at the positive electrode, we don't get any kind of oxide of nitrogen. Once again, like you do with the sulfate, you get O2, and that the oxygen atoms there are coming from the water. So there's a little rule here that if you have a halide ion, so a halide is chloride, bromide, not fluoride actually because that's too reactive, or iodide, any of those, they will give you the halogen at the positive electrode. But if you have any other ion at all, so we've got the sulfate ion there, that's in a different color, sulfate ion, yeah, the sulfate ion, the nitrate ion, the fluoride ion would also do the same thing, F minus, and say carbonate ion, that would also do the same thing. What you get there, any of those ions, you do not get something from those. You end up getting oxygen. They all give you oxygen as the product of the positive electrode, and that is coming from the splitting of water, as we'll see in a minute. So that's a rule. Only the halides give you those elements. Right. Okay, so here we have got the electrolysis of copper sulfate solution, and so in solution I'm going to have positive copper 2 plus ions, and also we're going to have some H plus ions. They're going to come from the water. Splitting water, here we've got H2O, it splits up and it gives us H plus and OH minus, as we saw before. A very small proportion of water always does that. It's 1 in 10 million molecules are split up in neutral water always. So you've got a small amount of H plus and OH minus ions in solution. So the other negative ion we've got there, in addition to the sulfate ions, we have got some OH minus ion there. Right, now we've seen what happens at the negative electrode. So this is pumping out electrons here, and so you're going to get copper 2 plus and hydrogen going to that electrode, and it's the copper 2 which takes electrons on because it's the least reactive. So that's fairly straightforward. So at this electrode, I'll just write it in green here, you get Cu2 plus 2 electrons goes to copper metal. Right, and we also, here's our positive electrode, is acting like a hoover of electrons, hoovering up the electrons. Now, which two ions are going to go there? Well, we're going to get our sulfate ion going there, and the hydroxide ion. The sulfate ions do not give away their electrons. They hold on to them. They don't react during the whole thing. So it's the hydroxide ions which give away, these hydroxide ions, they give away their electrons. So if we have a look here, you have, so the positive electrode, you're going to get OH minus is going to give away an electron. And actually, this is a bit complicated. You need 4 of them. You're going to get 4 electrons there. And you end up getting, so you've got an oxygen molecule and you reform a water. So you just check that's balanced, which it is, because you've got 4 oxygens on this side, 2 there. Oh, I need to put a 2 in front of my hydrogen water there, and it's balanced now. And we've got 2 oxygen atoms there. We've got 4 hydrogen atoms there, and we've got 4 on this side as well. So let's get rid of that. That is the equation that happens with the positive electrode. So oxygen is released. So you're going to get little bubbles of oxygen here. Okay, that's oxygen. Right. Let's think what happens to the solution that's left over then. Right, we can see we are continually splitting up water here. So right, our water is getting split up all the time. And those OH minus ions, well, they are getting removed. If you keep removing the OH minus ions, as we said before, that will push this equilibrium forward. So more and more water will keep splitting up as you remove the OH minus ions. So what is going to happen to the concentration of our H plus ions? Well, hopefully you can see there that the H plus ion concentration in the solution will increase. And if you've done the acids topic already, you'll know that anything with H plus ions in will be acidic. So the solution will become acidic. And let's just think what acid is in there. Well, we have got the sulfate ions. Well, sulfate ions don't react. They just remain hanging around. So we've got sulfate ions in solution, and we've got all the coppers. They're all going to go. They're all going to get turned into copper metal at the negative electrode. So there's the copper forming there on the electrode. But what's going to be left behind, OH minuses get removed, but what's the H plus from the water will accumulate. So you get H pluses. And if you put those together, you get H2SO4. So essentially that copper sulfate solution turns into H2SO4, which is of course sulfuric acid. So the copper sulfate solution will, as the copper ions are replaced, it will become paler and paler blue as the copper ions disappear. They're blue colored, and it will gradually form. You'll just be left with sulfuric acid at the end of the electrolysis. Okay, so hopefully you can see what is going on there. Right, now if you just talk about what's left over in solution, go back to the original table at the top here. Right, okay, so we said when you electrolyze sodium chloride solution, right, you keep removing the hydrogens from the water, so the OH minus ions accumulate, so you end up with sodium hydroxide solution there. Let's see what happens if you keep removing the OH minus ions, then and they get turned into oxygen. What's going to accumulate behind are the H plus ions from the water. So what's going to be left over at the end is going to be H2SO4. Let's think if you did it with nitrate ions. Well, you're going to keep removing the nitrate ion. Sorry, the nitrate ions don't change. You're splitting up water, forming H plus ions. Well, the nitrate ion will persist in solution there, but the copper will go. So you'll end up actually with nitric acid there, HNO3. That's what's going to end up there. So you'll get there. Okay, so should we see for one final thing, what would happen if you did sodium, if you electrolyzed sodium sulfate? That's quite interesting. So we've got sodium sulfate solution. So let's think about the positive ions. So you're going to have Na plus ions, and you're going to have H plus ions from the water. Let's remind ourselves, H2O is going to split up to form H plus and OH minus. So we're going to lose those H plus ions. They're going to go to form hydrogen gas. The sodium ions will be left in solution. At the negative electrode, sorry, the positive ions, let's call that the negative electrode there. Something in the negative electrode. Let's talk about what's happening at the positive electrode. Right, we're going to have sulfate ions going there from the sodium sulfate, and we're going to have OH minus ions from the water. Okay, now if you remember, the sulfate ions remain in solution, and the OH, they're the ones which get the electron removed, and that's going to form oxygen, and you'll get water there as well. Okay, beautiful. So that means what happens is, as you electrolyze sodium sulfate solution, you keep removing the H plus ions, you keep removing the OH minus ions. So essentially you are splitting up water. You're splitting water. What are the two products you get? Well, at the negative electrode you get hydrogen. At the positive electrode you get oxygen. So you've split water up into its elements. And what happens to the sodium sulfate? Well, the sodium ions remain behind, and the sulfate ions remain behind, so that just remains as sodium sulfate. Of course, if you electrolyze it for a very long time, it will get more and more concentrated as the water was splitting up. So basically, you were forming, what you're doing there is you're doing hydrolysis, which means splitting up of water. You're splitting the water up into hydrogen and oxygen.